Welcome to the fourth installment of this beginner series into game development with Unreal Engine 4. Today we're gonna start doing something pretty awesome. We're gonna learn about blueprints. Blueprints is one of the ways that you can create game logic in Unreal Engine. It is a visual scripting language that allows you to do sort of the programming without having to learn an actual programming language. It is very similar in how it works and it is very user friendly. So let's get into it. Today's tutorial might be a little bit big because we're gonna cover a lot of things. However, if there is one thing I want you to take with you from this, it is this. There are a multitude of ways to solve any problem. And some of them might be better, some of them might be worse, but none of them are necessarily wrong. They just might make it easier or harder to expand upon depending on what you're gonna be building afterwards. So all of the things that we see today can be done in a multitude of ways, some better, some worse. It's just a matter of how you're going to be implementing it. But we will be going through some fairly simple examples, and maybe not everything will be best practice. Anyway, let's get started. To start off, in case you do not have a programming background, we need to discuss a little bit about how classes work. Because blueprints are classes, and classes are basically templates. They define how an object in the world feels, looks, behaves. So the blueprint or the template dictates an object's behavior and look and feel. So you create an instance of the class to bring out into the world. So an object or an instance is what's in the world. You don't actually have classes in the world, you have instances or objects of a class in a world. We will be delving a little bit more in depth to this as the tutorial goes along, but for now that will suffice, I think. To have it as a reference to something in the real world, if you imagine you're going to build a house, you don't build a house just willy-nilly. You first have an architect that will draw you a blueprint of how that house is supposed to look, and that is why blueprints in Unreal Engine are so aptly named, because they correspond pretty well to a blueprint for an architect, for example. So the blueprint is defining how the house should look, and the house itself is the object that we create from the template or the blueprint in Unreal Engine. So a specific house or a specific instance of the object then would be in the engine. The relationship between classes and objects in the world is this. Imagine you've created a class, a blueprint, and you have made three instances. You brought in three instances of the class into the world. Each of these individual instances can have certain properties manipulated or changed so that they are different in comparison to the other instances of the object. But if you go and change something in the class itself, which is the blueprint that all of these instances derive from, then that change will be reflected onto all of them. Let us start off with the example that we're gonna be beginning with today. So we want to create a door today, a door that we can open. what we begin with first is that we make sure that we are marking the content folder of this project, and we're using Unreal Engine 4.26 today. This is a project that has starter content installed on it, so you're going to need that if you want to follow along. If we type door into the filter here, we will find a few items here, but among them we find SM door and SM door frame. SM is a prefix basically saying it's a static mesh. So we're interested in both of these items. So left click on the first one and hold down Control and left click on the other one, and then we drag both of them out into the world here. So they are not entirely aligned, so we will make sure to move the door slightly. And in this particular instance, we don't snap snugly within the door frame, so we will be changing the snapping distance from 10 to 5. That should allow us to get a more precise fit here. Now, you might have noticed that when we had the frame selected, we have our axis in the bottom middle of the frame, but when we have the door selected, it's actually in one of the corners. This is actually pretty good in this particular instance, because when it comes to rotating objects, you want to have it make sense. So if I was to rotate this door frame, then it will just rotate around its center, and that's what we would expect. But if we have it on the door, it will instead rotate around the point where the axis were, which is called a pivot point. And that will make the door actually look like it's opening up and closing, which is perfect for our purposes. So this is basically what we're going to try to accomplish today. We want a door that opens up like this. So this right here isn't a class. So now we're gonna create that class. So first we will erase this filtering. We will create a folder. Under the content folder we will create a folder called blueprints. This is to make everything structured, and it is probably good practice for you as well to name folders properly and structure your files in a good way so that it's easier to find. From here we will right click and we will go up to blueprint class. Now the pop-up we get here is a pop-up that takes into account something called inheritance. So let us discuss that. Inheritance when it comes to classes is the idea or the notion that if you have a particular class, let's say a car might have some common values among different types of cars. Let's say they all have 4 wheels, for example. But then you can create a child class based on this car class, because you want to make a Ferrari, let's say, a class for a Ferrari. And it is easier to create a Ferrari class that inherits from the car class, because then it gets all the characteristics that are common between cars, so that you don't have to do that for every class that you want to make. So let's say you want to have a class for a Volvo, a Porsche, a Ferrari, a Tesla. Instead of redoing everything that is common between these classes, you have all of the common denominators in a parent class that they derive from, and you just put in the differences from the parent class in those children's, and you also put in common denominators between those different brands of cars. So for example, the car class, like we said, would have 4 wheels as one of the properties in it, but the Volvo car, for example, would have common between all its counterparts that it would have a Volvo logo, for example. maybe the Ferrari class would have, let's say, all of their cars would have a higher minimum speed available to them, or something of that nature. Basically, inheritance allows us to be more efficient in our distribution of information, allowing us to reuse information in a better way. I will be showing some examples of this as well during the tutorial today. How that applies to Unreal Engine is in the following way. Like you can see here, it tells us to choose a parent class. These classes that we get presented here are the most commonly used ones. So these are the ones that you will 95% of the time be happy with using. There are more classes available, and you can get them by clicking this drop down here. So you see there's a lot of classes available here. And in addition to that, you will also be able to make your own classes, which would not show up here, but they would show up down here. When it comes to Unreal, an actor, actually not true, object would be the most baseline class that we have available to us. From that, actor inherits from object, so everything that object has, an actor has. An actor is any object that exists in the world, basically. So this is one of the most flexible use cases that we can use when it is relating to a class. So most of the times one would make probably a normal actor. In addition to the actors, there is something called a pawn. A pawn is a class that derives from the actor class, and it has the added functionality built into it that it can be possessed. So this represents everything that, for example, a player or an AI could take control of and manipulate in some way. A character is a class that is derived from the pawn, so it inherits from the pawn, and this one has further added functionality added to it compared to a pawn class. Player controller is not inherited from pawn and character. This is a class that is used for normally handling inputs from a character. So when a character plays a game, the player controller is actually what's the class that they're interfacing with, and that in turn would control either a pawn or a character in most cases through the means of possessing. When it comes to game mode and actor component and scene component, these are a little bit beyond what we will be going through today. Now, proceeding from here, we will be choosing an actor today. So you click the actor and we get to choose a name. According to what we talked about in earlier tutorials, naming conventions are good. A good way to denote that the object that you have is a blueprint is to prefix it with BP, for example. And then we can call this door, since this will be our blueprint that is a door. Now we open up the blueprint by double clicking on it. And this is what we get. So your window might look like this when you open it up, or it might look like this when you open it up. Like this. What happened for me, which may not happen for you, is that Unreal found that this was an empty blueprint, so it was just suggesting that it should just show me the parameters and details that belong to this empty class, and that I had no need of the other things, and that's why I clicked on the link that allowed me to see all of this. This window represents all the information that is available in the class. So to start off, in the top left here we have the components part. A component is basically a small modularized part of functionality that you can hook into a class. So this could range from anything like light or geometry like boxes and spheres, or meshes like the door that we're about to put in here, but also more advanced things like ability to move around and things of that nature. So in the top here, this part should look pretty familiar. It's resembling pretty much the main view in Unreal Engine when we're out looking in the map normally. On the right hand side you have the details, just like we have details when we go out and click on highlight on objects in the normal world. These actually correspond pretty much one-to-one with what we see in a specific class when we look at it. Other than that, the main window in the middle, this is our viewport, like it says up here in the tab. This is the visual representation of our class if we were to put it into the world. Right now, all that we see is this white sphere. It is there because of the default scene route over here. It is just to denote that this is an object here and this is the center of the object, just so that we know in case we don't have anything else to use as a reference. Other than that, we also see this grid underneath of it, or actually in the middle of it. This represents at which height the floor would be on. So if we put something here, we should keep that in mind, that we keep it aligned with the floor if we want it to be above the floor, or if in a situation you would want it to actually be a little bit inserted into the floor, you can make sure that you have it here aligned as well. The last part over here is the section that says My Blueprint. This part contains all of the actual gameplay functionality. So we will be spending a lot of time here today. But to get there, you also have some other things. The construction tab. This is a tab that you probably don't need that much use of. This is an event. This node here represents an event that is called every time this object is reconstructed. So for our means today, not that interesting. So we'll move over to the event graph tab. This tab, however, has more stuff that we will be working with. These three nodes are events as well. Today we will only be playing around with the top ones, so we can mark the bottom ones and press delete. The event begin play is an event that triggers when an object is brought to life, when it is created in the world. To represent this, let me show you. So we can, if you right click on the background and then you press print, type print, you'll get this node called print string. We'll hook this up from the begin play node. What this does is, when this object is created, it will type the word hello for us in a window. So when we made changes in blueprints, what we always want to do is press the compile button up here. Compiling is basically you're telling the engine to try and translate what you have done into code that it can understand. And if you get the green check mark like this, everything is fine. If something's wrong, you will get a red cross instead, and it will show you a window of all the problems it has encountered, and you need to change your scripting so that it solves those issues that have arisen for the engine to be able to use your classes properly. Another good routine to have is also to make sure that you save often so you don't lose work. So now we have compiled this very simple class let's go back to the world. If we were to start this world now, you see that we have this door and nothing happens. Up in the top left of this screen we would have seen a message if our class had been constructed, but it has not, because we don't actually have the class in the world. Why is that? Well, because you don't actually have classes in the world. The classes are the blueprints. They are the templates. They only exist down here. If we want to bring this into the world, like so, then what we've created is actually an instance or an object of the class. Now that we actually have an object or an instance of the class available and we press play, you'll see it says hello up in the top left. So far that means that this part that we've demonstrated is actually working as intended. Let us move on to actually making this look like a door. We go back to our viewport over here in this tab, and what we now know from what we spoke about earlier is that if we make a change to this class, it will be reflected on all the instances that exist of that class. So out in this world here we have this instance of the class already out. So anything that we do in here will be reflected there. What we will do now is that we will first undock this tab so that we can see it like so. We will scale it up a little bit so that I have some space up here in the components section of the blueprint, because now we will be actually adding the static meshes that I showed you earlier. So click on content, type in door again. We will have both of our hits from earlier. Now the static meshes work pretty much in the same way that classes work. So these are static meshes, but these are also static meshes. The difference is these are instances of these static meshes. Any change that will be made to these static meshes would be reflected over here. But equally, if I had multiple static meshes, instances of static meshes over here, and I was to change one of them, like for example I would scale this one, it doesn't affect this. But if I were to go in here and change so that the dimensions would be different, both of these would also be affected. So in that way, other objects also work in the same way as classes do when it comes to how they are affected by changes. Now that we're off that tangent, let's go back to what we were actually trying to do. We will left click on one of these, hold down Control, left click the other one, then we will drag these two static meshes and drop them up here in the component part. You'll see that immediately a door frame appeared over here where our object is. That is because they appeared over here in our viewport. So we will dock this again so we get some more real estate when it comes to viewport. Like we had issues with earlier, the door is not aligned with the actual door frame, so we will be moving that a little bit. Since I have snapping 5, it was easy to align it to the door frame. This looks pretty good. Okay, compile, save, good routine. So back in the map now we have static meshes of the door and we have a class of the door. Pressing play, we still get the hello message up in the top left. Okay. So what will we do from here? We can start off with disconnecting this print string over here. We can do that by holding down the Alt key and clicking on either this start of the connector or the end of the connector. So now that we have that selected, it will no longer show up hello when we start the level. But what we want to do now is we want the door to actually be able to open. That is, after all, the functionality of a door. So how do we do that? Well, now we will enter one of the components that is probably most widely used. You will probably have encountered this a bunch of times if you have played games before. Whenever you play a game where you walk into a room or an open area and all of a sudden you lose control of the character and the camera pans away from your character and shows like an awesome boss doing something frightening, or maybe some effect like particle effects or an earthquake or something like that happening. What has happened there is that you most likely walked into a volume which triggered an effect like a cutscene or some piece of logic. And that is what we will be adding today. A volume that allows you to sense when someone has passed through it, so that you then can react with your own piece of logic to that. So we will be going up here to add component. We will type in collision or col, and you see that we have three different ones under the collision here, which is a box collision, a capsule collision, and a sphere collision. So if we choose the box collision, this box over here is completely transparent and you can only see the outlines of it. This box is meant for what we just described, and you can see in the world, if we compile and save, that this box shows up as long as we haven't started playing, but as soon as we play it is invisible. So it's just there to show you that it exists and that is where it is, to make it easier to do things like debug and see where things are supposed to be, identifying and scanning for objects entering the volume. So what we want to do is have this volume so big that when a person comes near the door, we want the door to open. So for that to happen, we need to scale this. So we'll change to the scale tool, we will scale it up a bit, we will move it up a little bit so it's more in line with the door. Maybe scale it down a little bit further, move it down so it looks like it matches the door a little bit. We'll scale it a little bit on the side. That looks good enough. It doesn't need to be super precise. However, one part that is important here is that we scale it out from the door also. Because the point is, a player or some object is supposed to enter this volume for the door to open. And if we have it scaled down like this, that means they have to walk all the way up to the door before you can actually open the door, which could be what you want to have in your game. Maybe you want to have it so when they come to this distance from the door, then they get a prompt saying you are now able to open the door. But for us today, we'll be making an automatic door, which means that the player most likely will expect it to start opening a bit before reaching the door, so that maybe by the time it has reached the door opening, the door will be fully opened. So we will do something like this when it comes to the volume, and that will be okay, I think. Compile and save. After that we will be right clicking on this box over here that represents the collision volume. We will be changing the name to something like proximity volume. By being good with descriptions and naming of your objects, you make it easier for yourself and everyone else that's going to be working with the things that you make, because it's easier to understand what they are intended to do, unless box is really descriptive of what it's supposed to be, of course. Anyway, that looks good to me. We go back into the world, and this is what it will be looking like now. That looks good, I think. So how do we test this then? Well, we go back to the class, we click on the volume, we go to the details part of it, and Unreal has made it very simple for us here. They have created for us that volumes have a bunch of events that we can easily just hook into. And one of these events that we have available to us is the begin overlap event. Probably the most common event when it comes to volumes, I think, that will ever be used. And how you implement this is super simple. All you do is move over to this plus symbol, click it, and it has created the node. So this is the node where the event will be called from. So when someone enters the area that we have defined, this area within the volume, this event will trigger and code will execute. To show that this actually works, we can use our print string from earlier. Save, compile, go back to the world, jump in here. We don't see a hello up in the top left anymore because we unhooked. Let's go up to the door. Hello gets spammed 3 times. Now these messages would appear if any class were to pass through the volume, any other actor. But we don't want any other actor to actually trigger this event, since this is the event that will actually be opening the door for us. We want to find out that this actually is the player that's walking through here. And the way we do that is by doing the following. We go back to our class, we drag off from the other actor pin, we release the mouse key, and then we type in cast first person and character. Now, to explain cast briefly, casting is the process of getting a object and then trying to see if that object fits the mold of a different object. So we spoke earlier of how a character inherits from a pawn and a pawn inherits from an actor. Since we have a first person character here, it could feasibly be an object or a child class that we could say that, oh, are you this particular actor actually a character? And we can see this if we actually go back to the editor and we find our player first person character. To the right of first person character we can see that there's a link that says edit first person character blueprint. By clicking on that we get to this view. And this looks a little bit scary, there's a lot going on here, so we'll just click on the viewport tab for now so it'll be a little bit simpler. From here you can see that this class in the top right has a parent class, which is character. So first person character has a parent called character. Character has a parent called pawn. Pawn has a parent called actor. So actor could be cast to first person character possibly. So what we will do here is whenever this event is triggered, we will drag this execution node in here. That means we will try to see if it's a first person character. If it succeeds, it comes out of this node, this pin, and we'll drag it over there. So if first person character would trigger our hello, any other class would end up over here where we don't have any programmed game logic as of now. We compile, we save, we check if it still works. Hello gets printed. Excellent. So let's go back to our class again. We now have basically the whole execution start point for our code. Now all that we're lacking is the actual code to make the door open. So we will start off with holding down Alt, disconnecting the print string node, moving it a little bit aside, compiling, saving. So how do we rotate a door? Well, if we go back to the viewport and we select the inner door and we choose the rotating, we can see that by choosing the blue that is rotating around the z-axis, we actually get the result that we are after. If we drag it to maybe 90 degrees, looks like it looks open and good for us, right? So 90 degrees we want to keep in mind. We go back to our event graph. So what we want to do is we want to make our door rotate 90 degrees around the z-axis. How do we do that? Well, we have added it as a component to the class, static mesh door. So we'll left click on that and drag it out to the blueprint background and release. This represents a reference to the door that we have over here. So if we were to drag from the pin of the door and let go, and we type in rotate, actually rotation, then we see that we get a few results here. If we were to pick, for example, set relative rotation should work for us. This is okay, maybe we should briefly talk about relative and world rotation. World rotation is the rotation in the game world as a whole. It's like the absolute viewpoint, like looking up from above. A relative rotation can be in reference to a different object. For us, in this case, that would be the default scene route. However, we could have a more complex hierarchy here where the door frame, for example, was under the hierarchy of the door, and maybe the proximity volume was under the hierarchy of the door frame and such. And then we would have a relative, we could have a relative relationship between each of these levels. For us now, since they're all directly under the scene route, this will not be so complex. So all we have to do is take the execution node into the set relative rotation, and we should be able to rotate. Now the question becomes, how do we rotate? Well, we already found this out. We want to rotate around the z-axis, and we wanted to rotate 90 degrees. Okay, let's try that. Type in 90 in the z, press enter, compile, save. Always make sure to compile and save. We go back into the world, we click play, we walk up to the door. Bam! What happened? Ah, it's opened over there. Well, that looked a little bit jarring, didn't it? It was a little bit fast. Didn't feel very nice. So what can we do about that? Well, we have a very useful node actually for just this sort of behavior, which is something called a timeline. So if we right click on the background, we type timeline. At the bottom we have an add timeline. Let's call the timeline door opening. Now a timeline is sort of an ad hoc way of being able to do some animations. What it does is you can define a certain amount of keyframes. A keyframe is a point in time you define a certain detail. Let's say, for example, if your character is standing on the ground at time 0 and at time 1, meaning 1 second, it is 30 centimeters above the ground. By using a timeline or animation in general, having these two keyframes would allow an animation to proceed where it slowly traversed from being on the ground to 30 centimeters up in the air in that 1 second of time. That is exactly what a timeline allows us to do. So if we drag our node into play from start in the node, then we have defined that we want to start from the beginning of the animation, but we haven't set up an animation yet. So we'll double click on the node, then we'll get this window. This is pretty blank, there's nothing here yet. But we want to add something for it to work around. And an easy way to do this would be we click on the button that says F, which represents a float track. Then we'll get a grid here. By right clicking on the grid, somewhere near 0, we can click add key. So now we have created our first keyframe. If we were to click another time around 2 seconds and then right click and add another key, we now have 2 keyframes. So we decided earlier we want to move 90 degrees. Well, okay, so time 0, we click on the first keyframe, that makes it highlighted in yellow. We then can alter its properties, which is time and value. These are the 2 parameters that correspond to this particular keyframe. So we just type in 0 to get it to be exactly along 0 in the timeline. And then we say that value should be 0, so it starts at 0, it has no change. Excellent. Then we click on the second keyframe and we put it to exactly 2, so it's nice and tidy. And we say, okay, we want this to be the degrees that the door opens. We already came to the conclusion that we wanted 90 degrees, so we'll type in 90 here. And it looks weird, it looks like we lost a keyframe here. The reason is it's just very high up. If we click on these buttons, it will zoom the grid so that it will horizontally and vertically fill out, and we can actually see all the keyframes that we have available to us. So it will go from 0 at time 0 to 90 at time 2. We compile, save, and then we go back to the event graph. So what will happen now is that every tick in the game, and a tick represents a frame in the game. So if you were to have 60 frames per second, then you would have 60 ticks in a second. So every fraction of a second update will be called from this node. And we want to say, okay, we want to update our rotation whenever this is updated along the time. So we'll drag this update node into our relative rotation. But we don't need to have 90 here anymore, because we already defined inside here, if we double click in, that this track here should be what is our degrees in change. We can also click up here, right click where it says new track, and rename it to degrees, so it's a little bit more clear, and compile, save. We go back to the event graph and we can see that the output from here says degrees now. So we want to use the degrees we have from this timeline and use it instead of the hard-coded value that we put in here. So we can zero this out if we want to, but this is a value that doesn't fit into this. So the pins are not compatible. The reason for this is that this is a float value, a decimal value. The new rotation is actually a grouping of 3 values, one for x, one for y, and one for z, all of them being decimal values though. If we right click on the pin, we have an option to split the struct pin. This will break up the grouping into smaller components, which means we get our x, y, and z broken down, which means we can now use our degrees to put in directly into the new rotation for z. We compile, save, we go out and check, press play. Let's walk up to the door. Look, so smoothly it updated. Very nice. Okay, Back in our blueprint again. There are a few issues with what we have just done. And we will learn a little bit of a better code of conduct when it comes to this, because if you were to decide that you didn't like the rotation that is needed to open the door, you wanted to have 100 degrees for example, or 80 degrees, then it would be sort of a mess to go like, okay, I have the rotation over here, it comes from here, okay, I need to go in here and I need to redefine this and I need to find that key. It says 90, I want to put in 100. It's a bit convoluted. What you can instead do is have this be a little bit more flexible. So if we were to add a variable, which we haven't done so far, you have here on the left hand side you have variables, and a plus sign appears up here when we have it aligned with the variable horizontally. Click variable and a new variable will be created. We will be calling this degrees for door to open. It will be marked red because it will be default as the type boolean. You can see that up here in the details in the top right. We don't want a boolean, we know for a fact that we want something that has decimal value for it. So we click on the boolean and we get a drop down of available variables that we can choose from. So float is the one we're after, we're gonna be clicking that one. Click compile, save. So instead of the rotation in here, we want to press Alt and left click to remove the connection. Then we want to drag our degrees for door to open and release it on the background. We want to pick the get degrees for door to open because that will be our reference to get a value from this variable. So we want to have this amount of degrees to open, but then the timeline doesn't work anymore, because how do you use this value with this value to get the value that we want to have? It doesn't work. Well, we do this by using lesser values basically. If we say a door is supposed to go from 0 to 90, then we can only use it for degrees. But if we were to say that it goes from 0 to 1, the 1 could represent 100%, meaning the time when it is fully opened. So if we choose 1 here, and then we realign the grid again so it looks a little bit better, that means it will be 0% opened at the start and it will be fully opened in the end. Now if we go back to the graph, we can drag off. We should have renamed this. Let's go back and do that quickly. Right click on degrees. We type it percentage opened. It should be more descriptive. We go back to the event graph. We move stuff away a little bit so we get some more space. We take this value, percentage opened, drag it off, release it, and type multiply. You'll see a float and then a star float. That means float times float operation. That's what we are after today. There we go. We'll drag in our degrees for door to open in as the second input in this node. And the result between these two will be what we use for the Z. Compile and save, but we can't try it yet because we need to click on the variable itself. It has not been given a default value, which means it will be defaulted to 0. We need to change this to the actual amount of degrees that we want to have. So if we choose 90, enter, compile, save, go back to the map. Now we start playing. We go up to the door, and it's still working, it's still opening. Everything looks fine. We go back to the blueprint again, and we change the value from 90 degrees to 45 degrees. Enter, compile, save. Back to the map again. We again play. We go up to the door, it only opens 45 degrees. That's how easy it is to change variables or properties of the door now that we have it as a specific variable. In addition to this, we can learn a little bit more about instances by doing this. If we choose the variable, we click Instance Editable and Expose and Spawn. We compile, we save, we go back to the map. What we want to do now is we want to make a copy of this door that we have. So we will click on the blueprint, the object instance. We'll hold down Alt and we will move it so we get a copy of it. So now we have two identical copies of this blueprint. But what we just did before leaving the class was we actually exposed a variable that we had to decide how many degrees the door will open. This you can see over here in the properties, 45 degrees. And we spoke earlier about these doors are separate instances. So we can go to this door that's highlighted. We can put 90 degrees on this one, enter. And then when we press play and we walk up to the first door, that one opens 45 degrees. But when we walk up to the second door, that one opens up 90 degrees. So the same door, using the same class, can still have different properties that are on an instance level if you want them or need them to be. Now, the other rules still apply. Any change you make on the actual blueprint class itself will still be reflected in all instances of them, even though they are now quite individual from each other. So if we go back to the class and we were to go to the viewport and we say add component and we take a cube and we move this cube around a little bit, something like so, so it's slightly protruding out of the floor but not much. Compile, save, go back to the world. Okay, that did not show. Let's try it again. There we go. I'm looking at the wrong side of the door. There we go. So both of these doors actually got a new box added to them. So there, you always need to keep in mind that classes affect all the instances, but instances can have properties that differ from one another if you need them to. Now, to demonstrate a little bit about inheritance then. Let's say we want to make a child class of this class that we've already made. We will right click on the class and we have an option to create a child blueprint class. We will call this BP door child, will be just fine for our purpose today. So we'll go into this one, and to make this one visually different from the other one, before that you can see here that all the objects are still the same as the parent class has, but they're all inherited, meaning that they are outside of our ability to remove because they don't actually belong to this class. I can't remove this cube, for example, but I can still add things and change things. So if I were to add another cube here, I could place it on top of this one, compile, save, go back to the map, and now each class that I put out here of the class door will all be looking like the ones we've already put out here. But the BP door child has the additional box on top of it. But since it's a child, it will still inherit from the parents, meaning it will still have the door that's opening, just like the other parents do. So this is how you make functionality reusable, how you compartmentalize code and functionality so that you can save time by creating children and what the benefits of these are. This particular example might not be the best in terms of functionality gained, but you can still see that you get everything you've done before for free, and then you can build upon it further and make it more niche as the needs for that particular class arise. So that's all good and fine, right? But let's build upon this a little bit further. The door actually opens, but it doesn't actually close. Let's see what we can do about that. We open up the BP door class again. We click on the proximity volume. We go down to the fancy events that are available to us, and we look up the one that's called on component end overlap, which is actually the opposite of the one we did before. It is whenever something leaves the volume that we have created. Click the plus to add it, and we get this node available to us. It has a little bit of a different set of input parameters here, but it is generally very similar. So much similar, in fact, that we can actually do something a little bit fancy here. We still want to do the cast, because we only want to make this happen when first person character leaves the volume. But then, if that cast is successful, we can actually go right here into the reverse, meaning that when we leave the volume and it is the player, it will reverse this animation from where it was playing and update the door, just like the code we made before. Let's compile, save and try it out. We walk in, it opens, we leave, it closes. We walk in, it opens, we leave before it's opened completely, and it starts closing from where it were. All very smoothly. While we are at it, let's open up the door, not the door child, the door blueprint again, and we'll fix a tiny little bug, because when we have altered the behavior by having the reverse node executing on this event, what will happen is if we were to leave the volume and then quickly go back in, it would start playing again, but it would play from the start. So you want to move this this connection from play from start to play. So you can just press Alt and dislocate that and then put it in play, and everything should be working fine. Let us take a moment to reflect a bit over what we have done so far. We created a class and added some static meshes to it to represent our door. We added a volume so that we can detect things in proximity. We used some events. That fired when the first person character entered or left the volume, and then started opening the door by rotating it around its Z-axis. Then we created a giant class to demonstrate what you gain by class inheritance, and to show you that you can add things easily on children by adding some cube meshes to it to differentiate it from the parent class. Well done! You've taken your first step into a larger world. Hopefully you found this video helpful. If you liked the video, leave a like. If you did not like it, leave a dislike. Leave any comments or suggestions down below. Subscribe if you want to see more videos like this in the future. In the next video, we will be continuing to learn about what you can do in blueprints by examining blueprint communication. That is all for now. Keep on learning.